Hello guys, it's your boy Mathew Javier again. And now for today's vlog, we're going to I will introduce to you the summary of chapter 5, which is the Ethernet. So guys, the summary of the chapter 5, the Ethernet. Chapter 5 began with a look at an IP address. Basics. This include an overview of the binary decimal conversion process. It continued with an introduction to classical IP address, where we outline how the five classes of addresses are identified and the number of hosts that each address range support. The number of available class A, B, and networks were also calculated. So as I said that earlier, that the first, it's the IP address, which is the basics, are included in our discussion. The next one is an overview of IP address. Rules outline the 8 key rules with respect to host addressing, such as the rule that mandates the last host portion of an address cannot be set off to all binary OS or all binary ones. The concept and purpose of subnet mask was introduced, including its relationship to IP address, in defining the split between the network and host portion of an address. Default subnet mask values and when they are used were also examined. So, as you can see, it says that IP address rules are outlined of the 8 key rules. The 8 key rules that shows request to the host address it the most. So such as the rule mandates, the host portion in the address cannot be set of all binary zeros and ones. So it explains all the binary that zeros and ones is all the set of that all that is also cannot be addressed. Third one is a look at a private IP address, provided insight into the flexibility that using these addresses provides to organizations, as well as their purpose in helping to avoid the exhaustion of the current IPv4 address space. The special subnet mask associated with three private ranges was also examined, along with the ranges of addresses that each supports. An overview of subnetting, providing insight into reasons for deciding to subnet a network. It continued by determining that subnet and host per subnet requirements that should be determined when characterizing a network. The process for determining custom subnet masks was covered in detail, including an overview of how bits are stolen from the host portion of the mask in order to allow subnet to be defined within the address space. Calculating the number of subnets and hosts per subnet available based on given mask value were also looked at. That says that, guys, it all all of the reasons that this chapter 5 is being told you about is that the IP address development provide insight, that flexibility, Chuchu using this address provided to the organization. So guys, it is so very important to know more about the internet. So this so much information is you can this so much information is all you can read in the net acad. So guys, I will advise you to read more in the net acad. So the next one is, next we look at defining the ranges of addresses that were valid on the given subnet. including the process for determining the end of given range. This included an overview of ranges associated with Class A, B, and C addresses in custom subnetting situation. A subnetting challenge question was used to show how even questions that appear difficult are easy to solve if the rules outlined are followed. The subnetting shortcut provided an overview of a quick and easy method of determining both custom subnet mask and the associated address ranges. It can be used as a simple reference for exam purpose. So the next is the, the process of determining whether hosts are local or remote to one another was looked at next. We learned that the ANDing process provides a way to not only determine whether hosts are local or remote, but it also finds the network ID associated with a given IP address. A loop classes addressing providing insight into how addresses are now more commonly looked at this manner rather than by class. An overview of CIDR provided insight to supernetting, address aggregation, and slash notation. So guys, it a process of determining the ranges and the valid on a given subnet mask. So of all of it, Ethernet is the most widely used LAN technology today. It is a family networking of technologies defined in IEEE. Ethernet standards define both Layer 2 and the Layer 1 technologies. For the Layer 2, as I said that all IEEE standards, Ethernet relies on the two separate sublayers of data link layer to operate logical link control or LLC and the MAC sublayers. At the data link layer, the frame structure is nearly identical. For all bandwidths of Internet, the Internet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message that being sent. So, the two styles of Ethernet framing, IEEE Ethernet standard and the DIX Ethernet standards, which is now referred to Ethernet 2. The most significant difference between the two standards is the addition of a start frame delimiter (SFD) and the change of type field length in the field of 802.3. Ethernet 2 is the Ethernet frame format used in TCP/IP networks as the implementation of the IEEE 802.2 thirds standards. The Ethernet frame provides MAC addressing and error checking. The Layer 2 addressing provided by Ethernet supports unicast, multicast, and broadcast communication. Ethernet uses an address resolution protocol to determine the MAC address of destination and map them against known IPv4 addresses. So guys, each node of an IPv4 network has both a MAC address and an IPv4 address. The IP address are used to identify the original source of final destination of the packet. The Ethernet MAC addresses are used to send the packet from the one Ethernet NIC another NIC on the same IP network. ARP is used to map unknown IPv4 address to MAC address so that packet can be encapsulated in the Ethernet frame with the correct layer 2 address. So ARP relies on certain types of Ethernet broadcast message and Ethernet unicast message called IRP. Request ARP replies, the ARP resolve, and ABB for address MAC address and maintains a table of. So on the most Ethernet networks, devices are typically connected to point basics at the layer 2 full duplex. A layer 2 LAN switch weapon switching filtering based only on the OSI data link MAC address. A layer 2 switch builds a MAC address to table it make forwarding discussion, and layer 2 switches depends on the routers to pass data between independent ID subnetwork. So guys, in the chapter 5, Ethernet, it shows us that how the binary, the data link layer, frame structure, the two styles of Ethernet framing, the layer 2 that provided by Ethernet support the unicast, multicast, H node, and ARP relies on the certain types of Ethernet. So all of that is on chapter 5. So guys, and again, I am Mathew P. Javier, and thank you for watching our daily vlogs. So thank you and God bless to all of you.